Hello student, in the last lecture we have seen examples in question number 6, 7 and 8. Now we will take examples in question number 9 and 10. So question number 9 is, which of the following functions has a removable discontinuity? If it has a removable discontinuity, then redefine the function so that it becomes a continuous. So we check the continuity of the given function at the point x equal to 0 here. So given f of 0 is given here, function of that point is given 3/4, call equation first. Now we apply limit as x tends to 0 to this function on both sides. Limit of function f of x as x tends to 0 is equal to limit of e raised to 5 sin x minus e raised to x divided by 5 tan x minus 3x as x tends to 0. So here we adjust 1 here, means we add and subtract this 1, e raised to 5 sin x minus 1 and minus e raised to x plus 1 divided by 5 tan x minus 3x. So here we take these two terms and we take a minus common here, so that's why it becomes minus, because minus plus, so minus 1 and plus 1 we add this here in the numerator. Now we divide numerator and denominator by x here, is equal to x tends to 0 e raised to 5 sin x minus 1 minus we adjust here this, in this step also we divide numerator and denominator by x here. Now we divide this separately by x to each term, x minus e raised to 2x minus 1 divided by x here, whole divided by 5 tan x divided by x minus 3x divided by x. Okay, now we add this here the power of e exponential function, because we use here this formula, limit of e raised theta upon minus 1 upon theta as z is 0, it gives 1 here. The power of e is theta, in the denominator here theta. So that's why the power of e is here not x, power of e is here 5 sin x, so we add this here 5 sin x. So we divide and multiply by 5 sin x here. So therefore it is limit as x tends to 0, so e raised to 5 sin x divided by 5 sin x minus 1, then we multiply this 5 sin x. We divide and multiply by 5 sin x. We divide any terms, to divide and multiply any terms, and this x we write it here. So this x is here. So first term here. Now the second term. Second term is here minus. We adjust here 2 also here. Minus e raised to 2x minus 1 divided by 2x, we multiply and divide by 2 here. We add this 2 here. Okay, here add this with 5 sin x, and here add this is 2 here, divided by, whole divided by 5 tan x divided by x minus 3 only, because x will get cancelled here. Now we apply limit to each and every terms separately. Limit of e raised to 5 sin x minus 1 divided by 5 sin x as x tends to 0 into, take this 5 constant before the limit, so into limit of sin x divided by x as x tends to 0 minus this second term 2 into limit as x tends to 0 e raised to 2x minus 1 upon 2x here. Okay, whole divided by 5 into limit as x tends to 0 tan x divided by x minus limit of constant. Limit of a constant is constant. So therefore it gives 5 into its value is here. Okay. Limit of e raised theta minus 1 upon theta is 0, it gives 1. So its value is 1. Again its value is 1. Limit of sin theta upon theta as theta tends to 0, it gives 1. These are the formulae, basic formulae. Then minus 2 into limit of same first formula here, limit of this here, e raised to 2x upon 2x minus 1 as x tends to 0. As x tends to 0, 2 raised to 2x tends to 0 also, 5 sin x tends to 0 also here, and so first formula. And here we use this third formula, and limit of a constant is constant. So therefore 5 into 1, it gives 1 into, again it gives 1, minus 2 into, it gives 1, divided by, it is also 1, minus it is 3 here. So therefore it gives 5 into 1, it is 5 minus 2 divided by 5 minus 3. So it gives 3 by 2. 3 by 2. Call equation second. Call equations. So limit of that function is limit of that function as x tends to 0 is equal to 3 by 2, and our function is 3 by 4 here, different. So from 1 and 2, limit of that function is not equal to function of that point f of 0, and therefore f is discontinuous at x equal to 0. Here limit exists but not equal to, limit of this function is exist but not equal to function of that point, means not equal to f of 0, because f of 0 is here 3 by 4 and limit is 3 by 2. So therefore hence the discontinuity is removable. Hence the discontinuity is removable. Discontinuity is removable. So we redefine the function as follows. The function as follows, to make as follows, to make continuous at x equal to 0, continuous at x equal to 0, and so therefore our function is, again we write this, so f of x equal to e raised to 5 sin x minus e raised to 2x upon 5 tan x minus 3x for x is not equal to 0 and for e is equal to 3 by 2, 3 by 2 instead of this 3 by 4, 3 by 2. F of 0 is 3 by 2. For f of 0 for x is equal to 0 is 3 by 2 at x equal to 0. Hence we redefine the given function because the discontinuity is removable, and then we redefine the function to make the function is continuous. In this way, the given function is removable discontinuity, and then we redefine the function to make a continuous at x equal to 0. So example number second and third you may try to solve at home. Now we will take example number 4 here. So here given function f of x equal to 3x plus 2 for the interval here x is less than equal to minus 2 and greater than equals to minus 4, and for this interval x is less than equal to 6 and greater than minus 2. For this interval the function is 2x minus 3 here. So we check the given functions are continuous or discontinuous, or whether it is removable or irremovable discontinuity. So for this first interval, x is less than equal to minus 2 and greater than equal to minus 4, the function is given 3x plus 2 here. So therefore here our interval is here minus 4 comma 6, our domain is here. That's why we check the continuity at x equal to minus 2 only. So that's why x is less than or equal to minus 2, less than minus 2. That's why we apply left hand side limit to this function. So limit of function f of x as x tends to minus 2 to the minus here, left hand limit as x tends to minus 2 minus to this function 3x plus 2. So there is no simplification, apply directly, limit directly here. So 3 into minus 2 plus 2, it gives 3 to the 6, minus 6 plus 2, it is minus 4. So the left hand side limit is equal to minus 4. Call first. Now we take the second interval. For the interval x is less than equal to 6 and greater than minus 2, the function is here 2x minus 3. So since x is greater than minus 2, that's why we apply right hand limit to this function. Is equal to two x minus 3 here. So there is no simplification, that's why I apply a limit directly. 2 into minus 2 minus 3. So minus 4, 2 to the minus 4, minus 3, it is minus 7. Call equation second. And so the right hand limit of the given function is minus 7. So from first and second here, are not equal. So left hand limit is not equal to right hand limit. And so therefore its common limit does not exist. Limit of f of x as x tends to minus 2 only, its common limit here does not exist. And therefore hence the discontinuity does not exist. Therefore f is discontinuous. at x equal to minus 2. Hence the discontinuity is irremovable. Hence the irremovable discontinuity. The discontinuity is irremovable. We can't remove this discontinuity to make the function is continuous, because it is an irremovable discontinuity, because the limit does not exist here. If the limit is exist and not equal to that function, therefore it is a remove. We remove this function to make it is a continuous. Hence the discontinuity is irremovable. Now the next question number 10. First example. If the function f of x equal to root of 2 plus under root 2 plus sin x minus root 3 divided by cos square x for x is not equal to pi by 2. So E is continuous at x equal to pi by 2. Then find f of pi by 2. Means the given function is continuous at x equal to pi by 2. Given function is continuous at x equal to pi by 2. So we have to find the function of that point. Means point is pi by 2. So means we have to find the f of pi by 2 here. So since given f is function f is continuous at x equal to pi by 2. Okay, it means that by definition when we say that the function is continuous, if the limit of that function is equal to function of that point, then we say that the given function is continuous at that point. So therefore limit of that function equal to function of that point. So our function of that point equal to limit of that function. Okay, by definition, if the limit of that function is equal to function of that point, then we say that the given function is continuous. So already we have to given function is continuous at that point. At that point, which point? F of pi by 2. F pi by 2 is point here. So therefore, it means that we apply limit to this function on both sides. So the value of the limit of this function is nothing but f of pi by 2 here. So limit as x tends to pi by 2, sorry, it is pi by 2. Function is our function is root of 2 plus sin x minus root 3 divided by cos square x. Okay, so put here take rationalize here, rationalizing the numerator here, because it is irrational function. Rationalizing the numerator here. Okay, 2 plus sin x minus root 3 divided by cos square x into, we rationalizing the numerator here, 2 plus sin x plus root 3 divided by under root 2 plus sin x plus root 3 here. We are rationalizing the numerator. So then multiply here numerator and denominator into denominator here. It is equal to limit as x tends to pi by 2, limit of this function. When we multiply this root into root, so it removes the root sign to this function. It is 2 plus sin x. 2 plus sin x. Then minus into plus, it is minus. Root 3 into root 3, it is 3 divided by cos square x. So we write this cos square x by using identity 1. It is 1 minus sin square x. 1 minus sin square, because first identity sin square x plus cos square x equal to 1. So we have cos square x. So it is 1 minus sin square x into this bracket. Write down this term in bracket under root 2 plus sin x minus root 3. So it is equal to limit as x tends to pi by 2. So here 2 plus 2 minus 3, it is minus 1. It becomes sin x minus 1 here. Sin x minus 1. Okay. So, but here also, can we write this 1 in the form of square? Yes, it is square. So now, this is actually a square minus b square in the form of a square minus b square. So we know that the factor of a square minus b square, a minus b, a plus b. So that's why its factor 1 minus sin x and 1 plus sin x. These are the factors of 1 square minus 1 minus sin square x. And the second term as it is under root 2 plus sin x minus root 3. Oh sorry, it is plus root 3. It is plus root 3. So here, due to this factor, we take common minus sign. We adjust. So we take common minus sign. It gives plus 1 minus sin x. Because minus into 1 it is minus 1 and minus minus it is plus sin x. We adjust here this minus sign. 1 minus sin x, second factor 1 plus sin x, and in third term under 2 plus sin x plus root 3 here. Okay, now common factor will get cancelled here. So it is only 1 minus 1 divided by 1 plus sin x into under root 2 plus sin x plus root 3 here. Now apply limit separately. Limit as x tends to pi by 2 minus 1 take this minus sign before the limit in the denominator here. Denominator limit of 1 plus sin x as x tends to pi by 2 and into limit as x tends to 0 under root 2 plus sin x plus root 3. So it gives, so here limit of a constant is constant. So that's why it is minus 1 divided by, here we apply limit as x tends to pi by 2, sin pi by 2, 1 plus sin pi by 2. 1 plus sin pi by 2. It is 1 plus sin pi by 2 into, it is under root 2 plus sin pi by 2 plus root 3. And so therefore it is minus 1 upon 1 plus sin 90, sin pi by 2, sin 91, 1 plus 1 in the second bracket, 2 plus sin pi by 2, 1 plus root 3. And so 2 plus 1 is 3, root 3 plus root 3, and 1 plus 1 is 2. So minus 1 upon 2 into root 3 plus root 3, 2 root 3. And so it is equal to the final minus 1 upon 2 to the 4 root 3. So it is a f of pi by 2. Actually LHS is f of pi by 2. It is f of pi by 2. F of pi by 2. So it is the function. Hence we have to find f of pi by 2. Hence we have to find f of pi by 2 whenever we given the function is continuous at x equal to pi by 2. Now the example number 3rd in question number 10. Second example you may try to solve at home. So third example, if function f of x equal to 4 raised to x minus pi, 4 raised to x minus pi here, x minus pi plus 4 raised to pi minus x, here it is x minus pi, and here it is pi minus x, minus 2 upon x minus pi whole square, for x is not equal to pi, is continuous at x equal to pi. This function is continuous at x equal to pi, and then find f of pi, means we have to find the function of that point, means f of pi. That point is pi here. Already function is continuous. Since f is continuous at x equal to pi, it means that by definition of continuity, limit of that function is function of that point, or function of that point is equal to limit of that function. It means that if the limit of that function is equal to function of that point, then the given function is continuous already. So we have to give one function is continuous at x equal to pi. That's why we apply limit to that function as x tends to pi. So is equal to, our function is 4 raised to x minus pi plus 4 raised to pi minus x minus 2 divided by x minus pi whole square. So here, put here this interval plus h, x equal to interval plus h here. And whenever we put this interval plus h, then as x tends to pi, then h tends to 0. X tends to pi, then h tends to 0. Interval changes. As x tends to pi, h tends to 0. And here, when we put x equal to pi plus h, then take this pi in the LHS, x minus pi equal to h here. X minus pi equal to h here. Okay. So therefore, our function f of pi is equal to limit as h tends to 0. Interval is changes here. Interval is change because we put here, where there is x we put pi plus h. So 4 raised to, we put here x equal to pi plus h, x equal to pi plus h. Pi plus h plus pi and minus pi will get cancelled. It is only h here. 4 to the power pi minus pi, when we put x equal to this pi plus h, so again this plus pi minus pi will get cancelled and it is only minus h here. Okay, and then minus 2 as it is divided by x minus pi is h here, h square. So now limit as h tends to 0, we multiply numerator and denominator by 4 raised to h. We multiply numerator and denominator by 4 raised to h plus 4 raised to minus h minus 2 divided by 4 raised to h into h square. So now we multiply each and every term. Here 4 raised to h into 4 raised to h, like x into x, it is x square, like this 4 raised to h square, 4 raised to h whole square, same term, plus 4 raised to h into 4 raised to minus h minus 2 into 4 raised to h divided by 4 raised to h into h square. And so therefore h tends to 0, it is 4 raised to h whole square. Here base are same, in multiplication base are same, then add the power. So plus h and minus h, it becomes 0. So 4 raised to 0 plus 4 raised to 0 minus 2 into 4 raised to h upon 4 raised to h into h square. But the value of 4 raised to 0 it is 1 because the value of a raised to 0 is 1. So that's why it gives h tends to 0 4 raised to h whole square plus 1 and minus 2 into 4 raised to h upon 4 raised to h into h square. Actually, this is nothing but like this. Limit as h tends to 0, it is a 4 raised to h whole square minus 2 into 4 raised to h. We take this third term as a second and plus 1 divided by 4 raised to h into h square. So this is actually this is the expansion of a minus b whole square, like expansion of 4 raised to h minus 1 whole square. This is the expansion of, because a square minus 2 into a into b, 2 into a into b, 4 raised to h into 1, 2 into 4 raised to h into 1, it is 2 into 4 raised to h, and plus b square, 1 square is 1 divided by as it is here. So 4 raised to h into h square. Now we take this h square in the numerator here. So limit of 4 raised to h minus 1 upon, because here h square and this whole square also, we add this square also. So here whole square and limit, and in the denominator here limit of 4 raised to h as h tends to 0. So apply limit is equal to, this is nothing but limit of a raised to x minus 1 upon x as x tends to 0, it gives log a, it gives log 4 whole square here, because whole square, and in the denominator here when we apply limit as x tends to 0, it is 4 raised to 0, you may write this formula here, since limit of a raised to theta minus 1 upon theta as theta tends to 0, it gives log a by using this formula here. And so therefore, but the value of 4 raised to 0 is 1. So therefore it is log 4. 4 we write here 2 square divided by 1. 4 raised to 0 is 1. And so therefore, again here we use rule of log of m raised to n, it is m log n. So 2 log 2 whole square, and so this is, take 2 square is 4, and it is 4 log 2 whole square, 4 log 2 whole square. So this is the value of f of pi here. F of pi is here. F of pi is f of pi, function of that point, f of pi. Hence we have to find the f of pi if the given function is continuous at x equal to pi. And so today we will stop here.